In this video, I will show you how you can create your own components with the component type editor. We will create a component that allows a choice to be made between an interconnectable input value and an integrated sine signal with the following adjustable parameters: amplitude, frequency, and offset. The component type editor is an independent application within SIMIT simulation framework. The editor can be opened either from the Windows Start menu or by double-clicking on a component from the standard library. You can expand all the standard components or use them as the basis for your own components. The interface concept of the component type editor is consistent with that of SIMIT simulation framework. On the left-hand side is the project window, where you can quickly access elements of your project, such as connectors, parameters, calculations, and the visualization. On the right-hand side, in the Tools window, you will find graphics and internal signals and controls in task cards. In addition, you can open existing components in the Components task card and copy their functions to your current project. In the center is the Work window, where you can create graphics or functions, for example. Below this is the Properties window, which gives you fast access to the properties of a selected object. Firstly, I give my new component a name, in general, and then assign it to a library. Using protection, you can protect your knowledge with a password. Next, I save the component. After this, I define all the inputs, outputs, and internal variables. In Parameters, I can set up parameters for the component type. The values of the parameters are set individually for each component after the instantiation. In the Behavior folder below, variables with a memory, or so-called state variables, are defined in states. These are variables that store values from the past, such as the level in a tank. During the initialization process, I set the outputs to a fixed value in order to avoid undefined states when starting the simulation. Then I enter a function in the cyclic calculation. In the example, when there is a positive binary signal at the selection input, a sine signal with the following adjustable parameters is generated: amplitude, frequency, and offset. I have already standardized the frequency to the sampling frequency. In all other cases, I enter the input x0 directly into the output. To help with orientation, you can highlight the syntax in the Properties window. Input signals are shown in green and output signals in red. The keywords, such as if-then-else instructions, are highlighted in blue. Using the block keyword, I can define an instruction-based approach in which functions are processed sequentially. You also have the option of transferring frequently used calculations into the functions. The topology function is used only in contact or flownet components. In basic symbol, you can specify the appearance and behavior of the basic symbol using the task cards. For example, you can highlight the signal change in the selection input using an animation. In the link window below, you can create a symbol that can be defined completely independently of the basic symbol. Using the symbol, you can represent current simulation states by means of animations, for example. In order to use and monitor the basic symbol, in the final step, I define an operating window in Operating Window with the corresponding input and output controls and a graphic to give a clearer overview. After I have created the component without errors, it appears in the User Components window. From there, I can drag and drop the component onto my diagram in the same way as standard components and connect it with other components. I create the link symbol by selecting the component and pressing Ctrl-Shift. I can now position the symbol on another diagram. Double-clicking on the basic symbol or the link symbol opens the operating window. All the objects in the operating window can easily be dragged and dropped from the window onto a diagram. This allows you to create an overview diagram very quickly that contains all the components of your simulation project. After starting the simulation, you can configure the components in the operating window and monitor their effects. For example, you can see in the trend how the amplitude can be increased or reduced using the slider. This can also be represented using an animation in the link symbol. In addition, you can create differential equations with the component type editor. For example, you can represent the change in the reactor volume as the total of the volume flow into the reactor and the volume flow out of the reactor. The differential is shown in SIMIT using the $sign. In this example, a volume and thermal balance can easily be created. The component can then be instantiated by dragging and dropping it onto a diagram. I drag the link symbol onto the overview diagram and link the connections of the basic symbol. Then I drag the appropriate input and output controls from the operating window to my overview diagram. After starting the simulation, I can force a volume flow and heat flow through the inputs. From the animation in the basic symbol and the link symbol, I receive direct feedback about the state of the reactor. I can find out more details from the operating window by setting the reactor volume and height parameters in advance. Defining functions and differential equations in your own components with the component type editor and constantly developing your knowledge of the plant. Fast, flexible and easy.